recursive functions is really some interesting process. In recursion, the function calls itself. So, such type of recursive functions are mainly useful for repetitive processes. In this repetition, we have to specify a condition where to stop the recursion. And the recursive function, because it is calling itself, it becomes very compact. When we will write, you will see that. In case of recursive function, when each call, the parameter value approaches towards base case. Base case is the condition where to stop the recursion. When the base case is reached, it is evaluated without recursion and it is sent to previous call, then next to previous, next to previous. So in this way, it again comes to the original call. Every time the results are stored on the stack memory, the stack is the last in first out type memory. So in that case, whatever was the last stored, that will come out first. And at the end, the final result is available. Let's see how to write the recursive functions for simple problems. So we are writing the recursive problem for maybe for print first 10 numbers. This type of problems we have solved many times. This is a comment. So we must write this as a comment. So it becomes a comment. Now we need a function here to define. So let's define a function. So maybe int fun be the function. When the function is there, it is also defined like this. So curly. Let this function fun be the recursive function. Now here we want to print first 10 numbers. So in main, we'll just write that print first 10 numbers. Printf first 10 numbers. Okay, printf first 10 numbers. After that, we'll just call this function. Calling a function means giving a name, and we want to start from one number. So we'll give a starting value as 1. So from 1 onwards, the numbers will be printed. That's all we have to do. So with this, we'll call the function. In this function, what we'll say? We need a number. We are sending this 1 as an argument here. So here we must define that integer n, suppose. So n will be 1 here. Now here we have to print the actual values. So let's printf the value of n. So %d, maybe \n, and we'll print the value of n. \n, so that the values will be printed vertically. So initially what will happen? This 1 will go here and 1 will be printed. Now we want next to be printed, next to be printed. For that, in case of do while, for loop, we do the arrangement that n will be incremented using n++, or in case of for loop also we give n++. Here we will call the same function with the next number. So next number is naturally n+1. This calling will happen until the number is greater than or equal to 10. So we have to give a condition that if n is greater than or is equal to 10, then we have to stop the recursion. So return, suppose 1. So this becomes the base condition. And if n is not greater than or equal to 10, then what we have to do? We have to print the next number. So else, what we have to do? We have to just call the function fun with the next number. Next number is n+1. So we'll just call the function as n plus 1. So in this function fun, what it will do is, whatever its value of n will be printed. If n is up to 10, then it will be displayed. Otherwise, it will stop the recursion. So recursively, the same function fun is calling the same function fun with the next and next number. So let's run this. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first 10 numbers are displayed. Now in this case, the numbers are displayed from 1 onwards. We should write here \n so that the first number will be also displayed at a proper position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you want to print the numbers, suppose in the opposite direction, that means 10 to 1, then what we will do is here, initial value is 10, so it will display 10 here. Here what we should do is n minus 1, so from 10 to 9, 9 to 8, like that. And the condition will be, naturally, n should be, if n is less than 1 or equal to 1, then it has to stop. Otherwise, it has to display every previous number, 10, 9, 8, etc. Let's run this. See, 10, 9, 1, 10, 9, 8, 7. The function is calling itself. Okay. Now let's do something else. Now let's add first 10 numbers. Let's add first 10 numbers. So we can give the name of function and suppose sum. Sum be the name of the function. In main, we'll say that we have to print the sum of numbers. So let's give this statement here, that printf sum of first 10 numbers is, suppose, is, then sum will be %d, and this sum we have to print. The sum will come from the function, and the name of the function we have written is sum. So sum of 10. So with sum we are giving the argument as 10. I just make it here so you can see the complete statement immediately. So what is happening here? In main, only one statement, sum of first 10 numbers is %d. After %d, we have to put this. And what is the answer is? Sum of 10. Answer is sum of 10. How sum of 10 will be generated? The 10 will be going as a number here. Now we don't want to display the numbers, we have to add the numbers. So this process of addition will take place until the number is up to 1. So if the number is up to 1, return 1. Else what should be returned? Under this condition, the function will return the sum of 10 numbers. How it will return the sum of 10 numbers? Under the condition, the value of n is greater than 1, this else statement will be executed. Otherwise, if when n becomes 1, it will be returning 1. So initially n is 10, so else statement will be executed. Next 9, 8, so that we have to add this. So we have to every time add n and its previous number. So else we have to return n plus sum of n minus 1. N plus sum of minus 1. So in the first case 10 and 9 will be added. Then in that addition 8 will be added. In that addition 7 will be added. This process will continue until 1 is added. After that, the process will stop. So let's run this program. Sum of first 10 numbers is 55. Correct. We can have sum of any numbers. Suppose we want sum of only 5 numbers. Then we'll just write here 5. So we'll get sum of first 5 numbers. If you want sum of suppose 25 numbers, then just write here 25 numbers. It will do the complete sum and give us the result. You can check the result. Okay. Now let's do something else. We know factorial. So let's find factorial. Factorial of any number we can put. Now suppose initially we will find the factorial of 10. Okay. So we know that factorial means multiplication of 1 into 2 into 3 up to whatever numbers factorial you want. So here we want multiplication of 1, 2, 3, 4 up to 10. So here what we will write is in this main factorial 10 is, and let's call this function as fact. You can give any name and we want 10, so fact 10 will be. Now we have to write this fact. Fact. This 10 number will go as an argument here. We have to multiply the numbers until it is 1. So same condition will be there. But now what it will return is, it has to multiply the n number and fact. So factorial function is calling the factorial function with the next number as n minus 1. So starting number is n, next number will be 9. Next time next number will be 8. Next number will be 7. Automatically the n goes on decrementing and it gives us the value. So let's run this program. I think factorial of 5 is 120. I remember that. So let's initially find the factorial of 5. Factorial of 5 is, let's do it. Factorial of 5 is 120. So in this way you can do the factorial of any number. You can give a statement that printf enter number to find factorial. So user will enter the number to find the factorial. So this number has to be taken as a number. So we must define here int n. And we have to read this from the user. So scanf %d and n. So this number which user is entering is considered as n, and we have to send this number as an argument, and here we can say that %d factorial of n is this. So we have to now display two numbers, n and its factorial both. So user will enter any number and its factorial will be given using this recursive function, where the fact function is calling the fact function with the lower number than it. So let's run this. Enter number to find factorial 5 120. Rerun this. 10 factorial of 10 is this. We have to check whether it is correct or not. Rerun this. Suppose 8 factorial of 8 is this. So in this way the factorial will be found. In factorial or in sum, every time there is a repetitive process of doing the same thing, add the next number, add the next number, add the next number. and the number is just one digit. So it becomes very easy to write such programs in the recursive. Now let's do something else. Let's get a line from the user and reverse the line. So if it is ABCD, it will print us DCD. Okay. So let's do this. Let's do this here also. Let's name the function as reverse. Reverse. Let's give the comment as reverse the line. Reverse entered line. Okay. Now the line will be entered. It is not a number. So let it be initially void, blank. Okay. Now we must give message to user that user has to enter a line. So you can give printf or puts, any of this. So puts to bracket, enter your line. So user has to enter a line now. So user will enter some line. Okay. This line we have to reverse. So call the reverse function. Reverse. User will enter the line and we are calling the reverse function. Now what reverse function in the reverse function? Line is made up of characters. So each character will be read until the end of line. So we have to define a character. Suppose character K. Character K is defined. This character K will be read using a function getChar. GetCharacter will read the function. So the value of getCharacter will be equated to K. So K is equal to getChar. Now this value of K, it has to be checked whether it is equal to end of line or not. How to check whether it is end of line? We know that end of line is \n. So let us check whether this is equal to \n or not. So if it is not \n, then only we have to use it for the reversal mode. So if it is not \n, this condition is checked using the instruction F. So we will check the condition. If entered character taken in using getChar equated to K is not equal to \n, under this condition only the reverse function will be executed. If the character is equal to \n, that means end of line has come, then stop the reversing process. Okay, so reverse function is calling the reverse function, and this becomes the base condition that until this condition occurs, do the reversal procedure. When this condition is true, stop the reversal procedure. So if this condition is true, do this, and if the number is equal to \n, don't reverse. Don't reverse. Now whatever characters are entered, they are taken, they are put on the stack using reversal, and when the last condition occurs, one by one they will be taken out from stack. So naturally the last in character will come out first. So when you give put character, the last character will be coming out first. So in this way the last character will come out first and the line will be reversed. So let's check this program by running it. Let's run this program. Okay. Enter your line. enter your line. So I will enter a line, suppose A, B, C, D, E, F, G, H. What answer I should get? H, G, H, G, F, E, B, C, D. Suppose I give one more line. I am fine. This is my answer. What I should get? E-N-I-F-M-A-I. If you give here any palindrome, suppose. What is a palindrome? Palindrome is the sequence of letters or characters which is read same from left and right. Suppose madam, M-A-D-A-M, madam. You get madam. So, or suppose race car, R-A-C-E-C-A-R, race car. Race car is also giving the same. So in this way you can give a palindrome and check it is coming same. Okay, that's all.